Welcome to our journey through the cosmos as we explore the most amazing comets in history. From ancient civilizations to modern astronomers, comets hold a special place in our understanding of the universe. Let's start with perhaps the most famous comet of all time, Halley's Comet. This celestial celebrity graces our skies every 76 years. The solid nucleus of Halley's Comet is only about 15 kilometers across, smaller than the island of Manhattan. As Halley's Comet approaches the sun, the ice and dust on its surface vaporize, creating a glowing tail that can stretch for millions of kilometers. It's a time capsule from the early solar system, offering us clues about the conditions and materials present during that era. Now let's talk about a comet with a bit of a ghostly tale, Biela's Comet. Discovered in 1772, this comet was notable for its relatively short orbital period of about 6.6 years. In 1846, astronomers observing Biela's comet noticed something peculiar. It had split in two. Despite numerous searches, Biela's comet was never seen again. These meteors, known as the Andromedids, are believed to be the remnants of Biela's comet, a cosmic shower of debris left behind by the fragmented comet. Mark your calendars, folks, because 2024 is bringing a celestial spectacle our way. A comet so bright it has the potential to outshine even Venus. This comet, officially designated as C2023A3, Tsuchinshan Atlas, is already generating quite a buzz in the astronomical community. If predictions hold true, this comet could become visible to the naked eye in the fall of 2024, gracing our skies with its brilliance for weeks on end. Now let's rewind the clock to 1996, a year that saw a comet grace our skies in a truly spectacular fashion, Comet Hyakutake. Discovered just a year earlier by amateur astronomer Yuji Hyakutake, this comet quickly became a global sensation. It made an incredibly close approach to Earth, the closest cometary approach in nearly 200 years. People around the world were captivated by this celestial visitor, its long blue ion tail stretching across the sky like a cosmic paintbrush. Hyakutake was found to emit X-rays, a phenomenon never before observed in a comet. Let's journey now to a comet that has become synonymous with one of the most ambitious space missions ever undertaken, Comet 67P/Churyumov-Gerasimenko, or 67P for short. Discovered in 1969, this duck-shaped comet became the target of the European Space Agency's Rosetta mission. Launched in 2004, Rosetta embarked on a decade-long journey to catch up with 67P. Finally, in August 2014, Rosetta arrived at its destination, becoming the first spacecraft to orbit a comet's nucleus. In November 2014, after months of careful planning and preparation, Rosetta deployed its lander module, Philae, on a daring descent to the surface of 67P. This mission was the culmination of over a decade of work, involving scientists and engineers from around the world. The goal was to gather unprecedented data about the comet, which could provide insights into the early solar system and the origins of water and life on Earth. This was a historic moment. Never before had a spacecraft attempted to land on a comet. The tension was palpable as Mission Control monitored Philae's descent. The world watched in awe as the lander approached the rugged, icy surface of 67P, a comet that had traveled millions of miles through space. Philae, despite bouncing a couple of times before coming to rest in a shadowy crevice, had survived its journey and was ready to begin its scientific mission. The lander's unexpected bounces added an element of drama to the mission, but ultimately, Philae's instruments were intact and operational. This resilience was a testament to the robust engineering behind the lander. Over the next 60 hours, Philae worked tirelessly, collecting data on the comet's surface composition, its temperature, and its magnetic field. The lander transmitted a wealth of information back to Earth, providing scientists with their first close-up look at a comet's surface. These findings have been crucial in understanding the building blocks of our solar system. While Philae's mission was relatively short-lived due to its landing location, the data it collected continues to be analyzed today. The mission has paved the way for future comet exploration and has inspired a new generation of scientists and engineers. Philae's legacy lives on, reminding us of the incredible achievements that are possible through international collaboration and human ingenuity. Now let's talk about a comet that's a bit of a frequent flyer, Encke's comet. Named after the German astronomer Johann Franz Encke, who calculated its orbit in the early 19th century, this comet has intrigued scientists for centuries. Its frequent visits to our inner solar system make it a unique subject of study. Discovered in 1786, this comet holds the record for the shortest orbital period of any known comet, taking a mere 3.3 years to complete one lap around the Sun. This means that every 3 years or so, Encke's comet makes a close approach to the Sun, providing astronomers with regular opportunities to observe and study its behavior and characteristics. This frequent flyer status makes Encke's comet a prime target for astronomers. Its predictable orbit allows scientists to plan observations well in advance, making it easier to gather data and track changes over time. Observing Encke's comet helps researchers understand more about the nature of comets, their composition, and how they interact with the solar wind and other cosmic forces. Encke's comet is known to be shrinking, losing a bit of its mass with each pass around the Sun. This gradual loss of material is a common trait among comets, as the intense heat and solar radiation cause them to shed particles and gases. Over time, this process can significantly alter the comet's size and appearance. While Encke's comet may not be the most visually spectacular comet out there, its frequent appearances, and its ongoing evolution, make it a fascinating object of study. Each visit provides a new opportunity to learn more about the dynamic processes that govern cometary behavior, and the broader workings of our solar system. So, the next time Encke's comet swings by, remember that you're witnessing a small but significant piece of cosmic history in action. In 2001, humanity got an up-close and personal look at a comet like never before, thanks to NASA's Deep Space One spacecraft and its encounter with Comet Borrelly. Discovered in 1904, Borrelly had long fascinated astronomers with its unusual activity. Unlike many comets, Borrelly seemed to have jets of gas and dust erupting from specific locations on its surface. During this flyby, Deep Space One captured the most detailed images of a comet's nucleus ever obtained. Deep Space One's encounter with Borrelly provided a wealth of data that revolutionized our understanding of cometary activity and composition. Comets, those icy wanderers of the cosmos, have captivated our imaginations for centuries. These celestial nomads, with their glowing comas and trailing tails, have been observed and recorded by ancient civilizations, inspiring myths and legends. From the Greeks to the Chinese, comets have been seen as omens, both good and bad, influencing human history in profound ways. But what exactly are these celestial objects, and what can they tell us about our solar system? Comets are essentially time capsules, preserving the primordial material from the early solar system. By studying them, scientists can gain insights into the conditions and processes that prevailed over 4.6 billion years ago. A comet's nucleus, its solid core, is typically only a few kilometers across, composed of a mixture of ice, dust, and rocky material. This nucleus is often described as a dirty snowball, a term coined by astronomer Fred Whipple. Despite its small size, the nucleus holds the key to understanding the comet's composition and origin. As a comet approaches the Sun, it begins to heat up, and the ices in its nucleus begin to sublimate, releasing gas and dust. This process creates a glowing coma, a cloud of gas and dust that surrounds the nucleus. The closer the comet gets to the Sun, the more intense this activity becomes, leading to the formation of the comet's spectacular tails. The Sun's radiation pressure and the solar wind then push this gas and dust into two distinct tails, a dust tail and an ion tail. The dust tail, which is curved and follows the comet's orbit, is made up of small particles that reflect sunlight. The ion tail, on the other hand, is straight and points directly away from the Sun, glowing due to ionized gases. These tails, like celestial banners, can stretch across a significant portion of the night sky, creating breathtaking displays. Observing a comet with its luminous tails is a reminder of the dynamic and ever-changing nature of our solar system, a spectacle that continues to inspire awe and wonder in all who witness it. Let's journey now to a comet that has provided us with a tangible link to the early solar system, Comet Wild 2. Discovered in 1978, Wild 2 became the target of NASA's Stardust mission. Launched in 1999, Stardust embarked on a 7-year journey to rendezvous with Wild 2. In January 2004, Stardust made its close approach to Wild 2, successfully collecting samples of the comet's coma. 2 years later, in January 2006, Stardust's sample return capsule landed safely in the Utah desert. Analysis of these particles revealed a surprising diversity of materials, challenging existing models of solar system formation. Thank you for joining us on this cosmic journey. From the familiar glow of Halley's comet to the surprising discoveries of the Rosetta mission, we've explored some of the most amazing comets in history. Stay curious and keep looking up. The cosmos awaits.